Two blocks which are identical, same weight, are placed one on top of the other, whereas as you see from the diagram that we are applying a force on the lower block. So what is the largest force that you will apply on a lower block so that the lower block starts to before the lower block starts to slip? It means that before the lower block start to slip, that means that we are talking about that instant at which the lower block is intact and it has not moved. Okay, it means that the acceleration of the lower block is zero. That's information that we have get from this line. Okay, and if we are going to use it also when we will make equations. Okay, now both are identical, so they have a same weight, as well as you see the upper block is tied with a string. Okay, so first of all, if you want to find out the amount of or the magnitude of this force, then first step is that you have to make free body diagram. Okay, and what is that? So so students, before we draw its free body diagram, just quickly see what how many forces are exerted on it. So basically we will talk about the forces along x-axis, so which is 0 because this upper block is in equilibrium. And why it is in equilibrium? Because when you are applying force on a lower block, the upper block can slide, but it is tied with the string, so that's why this is a force of tension in the string which is trying to keep it in the same state of motion, which is at rest. Which force is opposing the force of tension? That is this force mu w, right? So remember that the mu w is the force of friction, kinetic friction, which is applied by the lower block on the upper block. So that is, so I'm going to draw the same force that will actually exert at this point. You see that mu w, so I'm going to draw this force mu w. There's another force, that is a force of friction applied by the ground on this weight on the lower block. So that's why there's another vector mu w. Okay. The other two forces, three forces, are these one. W, weight of the lower block, weight of the upper block. And the balancing force is this one. This is a normal force exerted on the lower block by the ground. And what about this force? This force is F, that is the applied force. Okay, dear students, so now let's apply the Newton's second law. I told you that acceleration is zero, which means that the resultant force, which is this one, mu w plus mu w, is equals to the mass of the lower block into acceleration is zero. Hence this is application of Newton's first law. So what we got, negative 2 mu w. This force which is applied by the ground on the upper block, lower block, should be 2 mu w. Okay, this must be the larger frictional force because it has to bear more weight. Okay, you understand? So that's why I am going to draw it longer vector. So that is 2 mu w. So overall there are how many forces which are opposing F? So that is 3 mu w is equal to 0, and hence the force F is equals to 3 coefficient of friction w. This is a magnitude of the force. That's why the option C is the right answer.